Even in those days, motorists were inclined to be impatient. Other traffic could be irritatingly slow. Reluctantly, the horse was giving way to the car, a transition greatly speeded up by the establishment in 1925 of Ford Motor Company of Australia. The year 1928. The last T-model had rolled off the assembly line. Change and progress were the words. Let's live it up a bit. The A model was the very latest in style, comfort, and performance. And then the first of the V8s. The family was really going places. Perhaps not fast enough for Junior, but certainly fast enough for Mum. 1934, and less than 10 years after its birth, Ford Australia showed how quickly it was progressing by designing and building the world's first coupe utility. Farmer and businessman were quick to see the advantages of a vehicle combining passenger comfort and ample load-carrying space. Manufacturing experience was further advanced with the production of the first steel body with a fabric top. And the first Australian turret top all-steel car body. 1939 and war. All facilities swung to full-scale war production. Nothing was too small or too big or too difficult to handle. If it had to be made, then experience and determination solved the problem. Even if, like this ship, it had to be built in the plants, assembled on the slips, and launched sideways into the water. During those war years, the company manufactured hundreds of small craft up to 250 tons displacement. Post-war, Australian content in all vehicles was stepped up, exceeding 80% in the 1955 Custom Line sedan and the mainline utility. Ford Australia was gearing up. Shortly after, Ford designers and engineers further demonstrated their ability and skill by the local production of the Zephyr utility. To be followed soon after by its companion vehicle, the Zephyr station wagon, both winning wide public acceptance by their modern, clear-cut styling, high performance, and attractive features. It had become obvious some time before this that the company must manufacture in Australia a high-performing passenger vehicle in the six-seater, six-cylinder class, and it had begun to plan accordingly. A study of the growing traffic on Australian roads had indicated the necessity to build a quality car with top performance, good fuel economy, comfort, modern design, and attractive styling. A car that could be manufactured in volume with a high local content, be competitively priced, and with ready availability of replacement parts from the outset, backed up by good service facilities. Ford Australia set itself to do just that. Australian Falcon, a car of sculptured styling, perfect proportions, a roomy six-seater with a lively six-cylinder 90-horsepower engine, splendid all-round vision, and built-in comfort and safety. A car backed by the resources of the worldwide Ford organization. Many years of planning and work, not only overseas but here, have gone into its design, engineering, and manufacture. And right from the outset, Ford Australia engineers participated in its development. And while the car itself was being evolved, Ford Australia had to equip itself to build it. This meant new plants, new facilities and machinery, new techniques. Every step of the way had to be foreseen in advance. 100,000 blueprints alone had to be drawn, studied, approved, and copied. A mountain of paper. Before an assembly plant that cost more than £9 million could be built and equipped at Broadmeadows on the outskirts of Melbourne. This, however, was only part of the big expansion necessary to manufacture the Falcon in Australia. Another £9 million was spent at Geelong, headquarters of the company, modernizing, expanding facilities, and establishing an engine plant. The Falcon engines are machined and assembled in the building on the left. And in the larger building on the right are the new chassis machine shop, tool room, and expanded stamping facilities. The white building on the side was necessary to house the extra presses. Special purpose machine tools were imported from Britain, Germany, United States, Holland, and France. But much of the equipment was supplied by Australian manufacturers. Installing this new equipment, precision machinery, to ensure high-quality manufacture was a gigantic task in itself. Every piece of machinery had to be located and installed on the exact spot planned for it, and all had to be placed and working to a strict schedule to meet the program data startup for each different operation. Delay would mean serious difficulties. While the expansion of plants and facilities got underway, Australian body engineers were working on the plans of the new car. Actual size drawings of the Falcon on wallboards assisted their study and enabled problems of design and manufacture to be discussed. They are then worked out in detail on the drawing board. Every measurement and curve and stress had to be checked. When you're working to extremely close tolerances, you can't afford to guess. Patiently and repeatedly, the gauge is run over every job. If it's a little high here or there, then it must be smoothed down. The die for pressing must be perfect and must match its mate exactly, for any imperfection here would show up in the pressed steel panels. High-quality Australian steel is used. Poured in Port Kembla mills, the steel ingot is formed into bars or long rolls. In the Ford manufacturing plants, the sheet steel is cut to the required size and fed into the mouths of giant presses. The jaws close, and depending upon the size and shape of the bite, dictated by the die being used, out come doors, floor panels, side panels, fenders, bonnets, and a host of other pressed parts. Here, a battery of lathes fashion bar steel into steering components. The bars inserted in the conducting tubes of this 6-spindle Gildermeister machine are held and cut by high-speed tools. They emerge as recirculatory ball steering shafts, each an exact replica of the next, and conforming to the fine tolerances demanded. Each is then butt welded to the main shaft. The steering and the front-end linkage of every car must satisfactorily pass a test to determine there are no cracks or flaws in the metal. Placed in this machine, the metal is magnetized and an iron oxide compound applied. The compound is attracted to any crack which distinctly fluoresces under special light. Detection of a flaw meaning rejection of the parts. Another one of the many new major pieces of equipment installed in the machine shop. Each double action, up and down movement, produces a complete set of door hinges for a car, 8 in all. Castings for the steering boxes are completely machined on this multiple lathe. After loading, the machine, it cost £54,000, carries out 17 different operations automatically. No matter what the part or the operation, there's a machine to do it. Either a lathe or a drill or a combination of both. Hundreds of different components must be heat-treated to bring the metal to the right degree of hardness. Heated to a predetermined temperature, they're then quelched in oil or other liquid solutions. All parts manufactured in the plant or provided by outside suppliers, as well as raw materials, must pass rigid quality and specification tests. In the quality control laboratory, chemical analysis ensures that the steel supplied comes up to the required specifications. Examination under the microscope reveals whether heat treatment of the steel has been satisfactory. But there are also very practical ways of testing parts, subjecting them to pressure and strains far in excess of any they will encounter in normal use. Clamped in the jaws of this machine, the metal is pulled and stretched to breaking points. Pistons in a crush test must stand pressure 100% greater than in the job they're designed to do. And axles are twisted 60,000 times each way on a bench. Note the movement of the chalk mark to make certain they'll stand up to torsion on the road. Flywheel ring gears placed in an engine stop and start 40,000 times, once every 6 seconds. These are not the only tests. There are many others, including grueling road runs, in which the parts are really punished over many thousands of miles. Every hour, every mile, designed to place the greatest strain possible on every section and part of the car. Hundreds of Australian firms have contributed to the building of the Falcon in this country. Between them, they've provided more than 1,500 different items, ranging from raw material for manufacture inside the Ford plants to completed components, such as sets of hypoid gears, axle shafts, differential cases and axle housing, crown wheels, pinions, operators test transmission parts before shipment to the Ford plants, where they again undergo rigorous checking. Pistons cast by one of the Australian suppliers are later machined by Ford operators at Geelong. A special machine accurately checks the balance of each drive shaft. A weight is welded at the exact spot indicated by the machine. Crankshaft and camshaft of the Falcon are poured at a Geelong factory. This is the first time these have been manufactured by the shell molding method in Australia. The same foundry also cast the cylinder block and head for the Falcon in a special grey iron. Removed from the mold, the block moves to a vibrating platform to shed the molding sands. In the Ford machine shop, each part of the engine undergoes many operations. The block must be milled, bored, drilled, reamed, and honed. There can be no margin for error here. Perfection is ensured by the use of the very latest automotive equipment in the world. Constant checking by ingenious air gauges is a further guarantee of uniform quality and finish to the closest tolerances. Precision machinery puts the finishing touches to the camshaft. It's machined and treated as it moves along the line. One of the most interesting processes is the hardening of each of the 12 lobes. They're induction heated and then lowered into oil. Nowhere does an engine component get through without checking. Quality depends on minute inspection at every stage. Ingenious equipment reveals the slightest departure from specification. Similarly, the crankshaft passes from machine to machine, each contributing to its perfection and fashioning it for the work it must perform. Again, the gauge tells the story. This component meets every test. Pistons supplied by the Australian manufacturer are here carefully machined. One of the manufacturing processes carried out in the motor plant is the making of the engine valves. Note how the head of the valve stem swells to a bulb as it's electrically heated. While still glowing, it's shaped by compression into the valve head. When all components have been machined and tested, they're delivered to the engine assembly line. Gradually, the engine takes shape from the machined block, each part fitting exactly into its right place. Each individual conveyor can turn the engine right round or be clamped in any position. An ingenious overhead rail system enables the conveyors to be diverted if required. When completely assembled, each engine passes to the hot test stand for a thorough check. Only perfection can get past inspection. When the seal of approval is given, it leaves the assembly line ready for transfer to the vehicle assembly plant. Inside the assembly plant, the car bodies quickly take shape in the body build jig. The conveyor line carries them through the Bonderite system, where the steel is treated to improve the holding quality of the body enamels. Through the underbody dip, where all concealed surfaces are coated with a special bituminous paint to prevent rust. Until the body reaches the final assembly line, where the engine, transmission and suspension are added. Front suspension is independent coil and ball joints. Rear is semi-elliptic. A car is born. This is the Falcon, the car you've been waiting for. Thousands of technicians contributed to its styling and engineering. Overseas, the car underwent 3 years of testing and 3 million miles of driving before it was accepted for production. Here, it's been subjected to the same exhaustive testing, driven over every type of road in the Commonwealth. Each is built to the same pattern of excellence, designed and engineered to give top performance and satisfaction, built to the highest standards of quality in the Australian automotive industry. But let's have a look at some of the features. First, the boot. Plenty of room. Including the spare wheel, there's 23.7 cubic feet of space. Doors are wide, giving easy access from both sides. Two-tone interior and door trim in a variety of attractive colors. Three-spoke steering wheel with the Ford deep dish safety design and well-laid-out instrument panel. A 90-horsepower six-cylinder overhead valve engine. And now for a few dimensions. Length, 181.2. Width, 70. Height, 54.5. Wheelbase, 109.5. A car with a proved background and a great future in this country. And there is a station wagon, one specially designed in Australia by Australian engineers for Australian conditions. It's now in production and will be released on the Australian market before the end of the year. With the rear seat folded down, there's more than enough room for a six-footer to stretch out in comfort. The chassis newly designed for greater rigidity and strength. Overall length carefully determined to handle our spoon-drained dips and depressions. Note the key and handle control of the back window. When locked, the handle spins freely. Here is the same sculptured styling as the sedan. It will offer the same comfort, have the same engine, the same quality finish. This prototype was given the most rigorous testing under the roughest road conditions, subjected to every type of stress and strain before being approved for volume manufacture. And again, yes, there is a utility. Smart, streamlined, and with an 800-weight carrying capacity. It will be released early in 1961. The panel van will follow. Sedan, station wagon, utility and panel van. That's the Falcon range. And each a good reason for happy smiles.